you can just watch the recording. Okay, so good morning, everyone. Sorry for the late changes, but we are on Zoom today. And the good thing about Zoom is I'm more comfortable using Zoom actually, but you guys prefer Google Meet. So we'll probably go back to Google Meet the next time our BIBD Alaf coordinator could join us again. Let me know if you couldn't hear me, if you couldn't see the screen, just let me know, okay? Now, this is a series of questions on chemical formula and equations. Mole concept is actually next week. Before mole, we have to go through chemical formula and equations. So these are a series of multiple choice questions. There are also a series of questions on the structured questions. So there's paper 2, chemical formula and equations. They were already posted a week in advance. Just like earlier today, I have just posted the question for mole concepts. So that will be the stuff that we go through next week. And you can feel free to go through those and ask me to go through whatever you want for next week. Okay, that's usually how this kind of tutorial will work. So I thought to start off, it would be quite nice for me to actually go through some of the important concepts. So I'll probably spend like 5-10 minutes on these introductory concepts. These are things you would have done back in year 9 or year 10, depending on whether you're doing the 2 years or the 3 years curriculum. You should be able to state the formula of the elements and compounds, because some elements are diatomic, like O2, N2, H2, whereas some compounds, some common ones include like CO2, carbon dioxide. You also have H2O, and then you have all those things from your covalent bonding topic, our syllabus, our learning objective from the last topic, CO2, H2O, CH3OH, C2H4, and many more. And the elements stated in the previous topic, H2, N2, O2, CO2, etc., etc. So those are just the formula of elements and compounds as stated in the covalent bonding topic learning objective. Deduce the formula of a simple compound from how many atoms do you have or how many ions do you have. This one is a result of your valency. So valency is just this number of electrons where your atoms need to lose or gain or share, because you share electrons between nonmetals and nonmetals that result in covalent bonding. You lose and gain electrons when your partners involve metal and also nonmetal atom. Your metal atom will lose, and your metal atom will form cation. They will form positive ion. Your nonmetal atom will gain electrons, and then they will form nonmetal anions. So you have nonmetal and metal forming ionic bond there. Okay, just give me a minute. I'm just going to make sure that everyone is already muted themselves. People who have just joined us, so you can catch the earlier recording later on, but you didn't miss much. I'm still going through the syllabus. Deduce the formula of an ionic compound from the charges of the ions. Ionic compound is uncharged. This is the most important thing. Compound is uncharged, so that means the charges must cancel out. Positive must combine with negative, so that means the charges must cancel out. That is the most important concept there. These are some of the general ideas about group 1 metal. So we know about the metals, the group 1, group 2, and group 3, they will lose electrons. When they lose electrons, group 1 will lose the 1 outer shell electrons. So the combining power called valency, how many electrons do you need to lose or gain or share in order to have a fully filled shell to complete your valence shell? So that means you will, I hope people can, hang on, yeah? Yeah, okay, people can still hear me. That's all right. So group 2 will lose 2 outer shell electrons and your valency is 2 and so on and so forth. Can people still hear me? It just informed me that something is wrong with my speaker. Can people still hear me? Maybe not. Okay, let me just try another way. Can people still hear me?
Yeah, I can hear you, sir.
All right, okay, that's all right. Okay, I thought people couldn't hear me. Now, the group 4 are nonmetals. The nonmetals onwards could be gaining or could be sharing electrons. So how many electrons do you need to share or gain to complete your outer shell? That is the valency for the nonmetals. In terms of the group 8, we said the valency is 0 because they do not form compounds. There is no bonding at all. They just exist as single atom. That's what you call monoatomic or monatomic. And of course, transition elements, if you are in year 10, you probably have done metals and you have done transition elements, transition metals, the middle block of the periodic table that can have many different number of valency because they can have different oxidation number. They can have more than one valency. There's ion 2, there's ion 3. So the valency of ion 2 plus is 2. The valency of ion 3 plus is 3, and so on and so forth. In terms of the table of ions, so there is a table of ions which you're supposed to know. Different teachers, different school, different notes, different textbook, they have different arrangement of these ions. What is important is group the group 1 together, and they will form +1, +1, +1. Elements in the same group that have the same properties, and then group the group 2 together. Elements in the same group that have the same properties. The metal form +2 cation there because group 2 metal have 2 outer shell electrons, and so on and so forth. There's group 3. And then we have these bunch here, which are transition elements. So these are transition elements, which can have more than one different valency, more than one oxidation numbers, according to this Roman numeral in the bracket there. There are some important ones for the non-metals. So these are the group 7. The group 7 elements are called halogens, but the ions, they are fluoride, chloride, bromide, iodide. The most common mistake students make is in spelling. They will call something like sodium chlorine, which is wrong. It's sodium chloride because these are ions and these are called halide. They have an IDE. Halide ion, that's the general name for the family. Halogen molecule is for the molecule. These are chlorine, fluorine, chlorine, bromine, iodine. These are what you call halogen molecule. These are what you call halide ion. Now, these all have a -1 charge because they all want to have 8 fully filled outer shell electrons. Because they already have 7 outer shell electrons as a group 7 element, they will just want to gain 1 electron to complete the outer shell there. Similarly, you have the oxygen and sulfur, which are group 6. They want to gain 2 electrons to complete the outer shell. And then the group 5 wants to gain 3 electrons to complete the outer shell when they form ions. But also remember that the nonmetals can also share electrons. So not necessarily they will form ions. Only when their partner is metal, then you get a transfer of electrons from the metal to the nonmetal. Only then they will want to gain electrons. Otherwise, nonmetal and nonmetals, from your last topic, they will form covalent bond. Now, there are a lot of these polyatomic ions, and students are always getting confused about these polyatomic ions. You know these are in your paper 3 practical studies, but you also know that as a result of COVID, you are most likely not going to do practical paper. You are most likely going to do an alternative to practical. And as such, if you are not doing a practical paper, you need to be very careful. The 2 pages, there are 2 pages of tests for cation, tests for anion, tests for gases. So all those tests, they will not be given in a theory paper. They are never ever given in the theory paper. They are only given in paper 3, practical paper. So be very careful. You need to know all those tests. And as a result, you need to know the formula of cations, anion, and the gases. Now, these are some of the popular anions. Test for nitrate, NO3-, test for sulfate, SO4-. The hydroxide is what you use to test for cations. All your cations, you add some sodium hydroxide aqueous, so that's OH-. Test for carbonate, CO3 2- there. There are something else which are in the theory, but it's not really in the 2 pages test in paper 3. You will do well if you go to your syllabus on chemical analysis. You will see that SO3 2- sulfite is in the theory, but it's not in the practical. So, you know, it is in the syllabus. So make sure you know the name and you're not getting confused between sulfite and sulfate there. They have different number of oxygens. This is pronounced as SO3 2-. Is the less common one, sulfite with the ITE. This is the more common one, sulfate, SO4 2-, come from sulfuric acid, H2SO4. Nitrate comes from nitric acid, HNO3, give you NO3- there. Okay, now going back to in terms of formula. So I think most people are okay with this. I'm just going to show you one example. So what I normally do instead of following a fixed rule is I look at the ions, the cation and anion. The first thing I do is I label the valency of the ion, follow the charges of the ion. So that is 2, that is 1, follow the charge there. And what is the number? Everyone, all of you, you should know what you're doing when you do these crisscrossing. So this is called crisscrossing. Some people call it cross multiply. What you're doing here is called lowest common multiple, which is a primary school mathematics. What you're doing here is to balance the charges because ionic compound is uncharged, and they were stated in the syllabus, you need to balance the charge for the ionic compound. So 1 goes to the left, 2 goes to the right. This one means how many. The label is how many. It means you have 1 of this thing on the left, so 1 Zn 2 plus, and you have 2 of the Cl minus. So your formula will have 1 Zn and 2 Cl2 like that. When you come across Na plus and SO4 2 minus, there's sodium sulfate. Now that is the valency based on the charges of the ions, based on the charges of the ions. Here is a bit tricky because of the polyatomic ion. Then they make it look complicated, but again, exchange the valency. And what does it mean? It means how many, okay? So people might know what they are doing. It's like, oh, I just know it just works, but you're not able to explain it. It's because of lowest common multiple. You have 2 of these Na plus and Na plus. Plus 1 and plus 1 is plus 2, and you have 1 of these sulfate, each of which is minus 2. Plus 1 minus plus 2, cancel out minus 2, the overall compound, Na2SO4, compound is uncharged. Ionic compound contain ions which are charged, but ionic compound is a compound is uncharged because the charges of the ions cancel out because of LCM, because of this crisscross of the valency there. Aluminium sulfate, the last one that I'll probably do with you. So this one is 3 for the valency and 2 there. And when we do the crisscrossing or the exchange of the valency, and we make sure that these are the simplest whole number ratio, this one means I have 2 of the Al3 plus, and I have 3 of the SO4 2 minus. So that means I have 2 of that. Now the problem is I have 3 of the sulfate, and because these are polyatomic, poly means more than 1, atomic more than 1 atom, I put them in a bracket and I have 3 of it. So 2 of these and 3 of that. Minus 2 times 3 is minus 6, plus 3 times 2 is plus 6. Lowest common multiply, the charges cancel each other out like that. You should also know, I did say there was the last one, but I should probably show you this one because this is interesting. You do not write Fe2SO4 twice, that is wrong, because these are not the simplest whole number ratio. When you do LCM, LCM of 2 and 2 is basically 2. So, you just need to have 1 of these and 1 of these because the simplest whole number ratio is going to be divisible by 2 there. So such that you have 1 of that and 1 of that. Plus 2 will cancel out minus 2, which is why the formula of iron 2 sulfate is FeSO4 and not the one that looks something like that. Okay. The next thing is you should be able to construct word equations. Simple equation means balanced chemical equations. So there's balanced chemical equations. And last but not least, ionic equations. Ionic equations is the simplest one. Show only ions and also molecules, because molecules cannot dissociate into ions. So you have to remain them as molecules. Things like CO2, things like NH3, things like H2O, they remain as molecules on the product side. You cannot dissociate them further. Including the use of stat symbols. Of course, there are 3, there are 4 actually: solid, liquid, and gas. Aqueous mean dissolve in water. So you need to know your solubility rules. This comes in a later topic, but I guess you must have heard of solubility rules, like all of Na plus, K plus, NH4 plus salts are soluble, all of carbonates are insoluble except for blah, 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 sodium, potassium, and ammonium carbonate. And sulfate, you got barium sulfate, which is insoluble, and some other stuff as well, etc., etc. Now, did you use the symbol equation with stat symbols for chemical reaction given information? So a question will give you some information, then write a balanced equation with a stat symbol based on the question. I just want to highlight a few things. Hydrochloric acid, the most important acid you can have. Well, sulfuric acid is important as well. Nitric acid is important as well. If you don't know the formula of these, you're going to struggle in any chemistry course. The chloride salt comes from this acid. The sulfate, not the sulfide, comes from H2SO4, and this nitrate comes from nitric acid. Now, there's always a difference between HCl gas, which is your diffusion case study. So it's not HCl aqueous that diffuse, it's a HCl gas that diffuses. Diffusion was topic 1, states of matter, kinetic particle theory. This is a simple covalent molecule. If you remember your dot and cross diagram, it looks like that. If you have done acid and bases topic, you will know that this is aqueous and aqueous. So you know that it's a mixture because aqueous there means in water. So you have the ions that are dissociated, and these are free ions, and they can conduct electricity in water. You use acid in the car battery. Your car battery can conduct. When you start your car engine, that is your acid. Not this acid, but sulfuric acid is also H+, but sulfuric acid is used in the car acid battery. This is a gas. This is simple covalent molecule, so it doesn't conduct electricity at all. Make sure you know the difference between hydrogen chloride and hydrochloric acid. Two different things. They look similar except for the stat symbol there. These 5 general equations, even year 11 students sometimes don't even know that there are 5 general reactions that you have to know. Metal with water, you also cover this under periodicity as the chemistry of metal. You also produce hydrogen gas. Anything with hydroxide is going to be basic. So when metal reacts with water, they will give you the hydroxide. This is an alkaline or basic solution. Metal plus acid, metal carbonate plus acid, these two are reactions of acid. They will give you salt. Acid reacts with metal or metal carbonate to give you salt, and these are metal salt, chloride, or nitrate or sulfate, depending on which acid you use. You get hydrogen gas if it is metal plus acid. You get carbon dioxide gas if you have carbonate. Now, these tests for hydrogen gas, tests for carbon dioxide gas, the tests for gases are usually asked as part of paper 3, as well as any theory level paper. Test for hydrogen, use a burning or a lighted splint, it will give you a pop sound. CO2, it will turn lime water milky or cloudy. Acid and base is your classic neutralizations. They give you metal, salt, and water. And you should know the Ionic equation. Every single acid has a H+ aqueous. Every single base dissolved in water has this OH- aqueous. I'm just writing Ionic equation. So it doesn't matter what acid I use, doesn't matter what base I use. I just have the water. This is called Ionic equation because I don't care about the anion here. I don't care about the metal cation here. I don't care about the metal salt here because those are spectator ions. Ionic equation only show the important bit. The aqueous acid, the aqueous base give you liquid water. The next one is your test for ammonium ions. In the laboratory, test for NH4+ is the test for ammonium ions. You need to add a little bit of sodium hydroxide. That is stated in the paper 3, 2 pages test for ammonium ions. You know that because you also have to learn it in the theory paper. Test for the ammonium ions, add some sodium hydroxide, and then heat it. When you heat it, you're going to get ammonia, and you're going to get water. These are molecules, they do not dissociate further. So these are gas and these are liquid. This is an alkaline gas, and the test for gas, again, test for this gas, test for NH3. This one is a pungent gas. It will turn moist red lemon paper blue. So, dampen or make your red lemon paper a little bit wet, and it will go from red to blue. That is the test for ammonia gas. The question is really, why does this add with this give you ammonia and water? Well, I'm going to write Ionic equations. So this is a classic Ionic equation for what happens when ammonium reacts with hydroxide. Look what happened there. The NH4+ will donate the H+. And H+ donor is what you call acid. So it loses the H+, it donates the H+. The OH- is acting as a base. What does it do? It accepts the H+. Think about your neutralization, the OH- bond with the H+ to give you water. This takes away the H+, this loses the H+. When this loses the H+, you get back ammonia and you get water. This one is not called neutralization because even though you produce water, this is not a salt, this is a base, this is alkali, you do not end up with pH 7, and therefore you don't call this neutralization. In the lab, they call this displacement of ammonia. This is one of the ways you can produce ammonia in the school laboratory here. I'm not going to bother with these word questions. I know I haven't uploaded this thing in the Google Classroom, so I'll do that at the end of the sessions, and you can play around with these. And these are actually what I use in my lesson tutorials. So you can catch my topical playlist where I actually discuss this in greater detail in the lesson tutorials for the topic by topic lesson tutorials, okay? So I'm going to skip all that. I already talked about Ionic equations, so I don't want to talk too much about that again. We'll probably just jump straight to questions, actually. So yeah, feel free to actually go through some of these, and then it can hopefully help you in addressing some of the questions that you will face in the future. or okay, in terms of preparation, you're probably going through the topics as well. All right, so there's around 20 minutes already. We are halfway through, so perhaps we can just turn on our camera and let's just take a quick photo for attendance so that I can show BIBD Alaf that you are present. So let's all just turn on our camera for a little bit. Where am I? All right, Shakila, are you there? And Shami, are you there? Good morning, everyone. Hope you have a productive morning. Okay, so we're just waiting for Izzuddin. Is Izzuddin ready? Probably not. Sorry? Oh, okay. All right, smile. 1, 2, 3. Okay, let's do that again. 1, 2, 3. Okay, all good. We can just turn off our video and they will save a lot of data on your side and on my side as well. Okay, now let's just continue sharing our screen. I hope you had a chance to go through the paper already. Yeah, I know it's hard because you don't have the paper next to you. You're looking on screen and you are also looking at what I'm doing on the screen. So perhaps it's best if you actually go through the question in advance, because I already posted a question always a week in advance. Yeah. So we'll go through the equations, chemical formula equations this week. So there is paper 1 and paper 2, as I mentioned. So this is the paper 1. And then there is the paper 2 as well. So whatever you want me to go through, shout out paper 1 or paper 2, and then tell me the page number. Okay. Anything? Or you're just waiting for me to go through for you? You see, learning doesn't work this way. Yeah, okay. I already went through the lesson, just like your teacher will have gone through the lessons. So there must be something that you feel uncomfortable doing, and that is when you take charge. You become responsible for your own learning, and you tell me what kind of thing you are not very comfortable doing as you go through the questions. Okay, we can go through paper 1, paper 2. I mean, we have another half an hour. What do you want me to go through? Anyone got questions? Because the whole session is going to be a bit pointless if I don't go through anything at all. Anyone got anything to ask? Perhaps you're looking.
Paper 2, sir.
Okay, sure. Okay, what kind of thing do you want to ask? Do you want to ask empirical formula, balancing equation? Any particular question?
About calculation, I'm not sure. November 2006, B9.
2006, B9. Okay, so this is about empirical and molecular formula. So the calculation in this short topic does not cover more concept. Yeah? Next week is the really, really big concept. You guys should really go through the more concept first. Otherwise, it will be tricky for me to go through everything. You must find out what question you want me to go through for next week, okay? So here, for 3 marks, you are asked empirical and molecular formula. The first thing you do is you need to be able to read the question. So do not hesitate on underlining or circling or whatever when you read the question. It's called annotating. Annotate means you circle, you underline, or you scribble because they just mark your word. Whatever it takes to get to the thing, okay? We are not, English is not our first language. So, we are not going to be well-versed in reading the first time and get it. So there's 0.18 gram of carbons, 0.03 gram of hydrogen, 0.08 gram of oxygen. This is butanoic acid. You will learn more about this in the organic chemistry section under carboxylic acid. Doesn't matter at this point. We're just doing carbons, hydrogens, and oxygens. We're going to know about definition. This is what you're thinking in your head. What is meant by empirical formula? Empirical formula is defined as the simplest whole number ratio. And they can ask you for 1 mark. What is meant by empirical formula? Simplest whole number ratio of atoms. Now, this is the key concept of atoms, because that means when I do empirical formula, this is atom, and this is atom, because of the definition, simplest whole number ratio of atoms. What is molecular formula? Molecular formula is the actual number of atoms. But then that is 1 mark. You have a second mark, which is the in one single molecule. So that means when you have molecular formula, you must have simple covalent molecule because Only then you can have individual molecules. In one single molecule, how many atoms are there actually? Now, the first thing in your working is you're going to write down mole. Mole equal to your mass over AR. Why do I say AR then? Because it's of the atom. So straight from your periodic table. Okay. Now, of course, some teachers will say write down the mass first. Yes, you should write down the mass first. Okay. But then I'm going to divide that by the AR. From your periodic table is 12. From your periodic table is 1. From your periodic table is 16. Why did I not divide by 2? Why did I not divide by 32? Because I know my definition. So the people who divide by 2, the people who divide by 32, they don't know definition of empirical formula because they think about the element instead of they think about atoms. Definition said simplest whole number ratio of atoms. So then I press my calculator. Oops. So press your calculator and make sure you can press your calculator correctly because we know some people cannot use their calculator at all, which is a bit of a shame. And your calculator will show you 5 times 10 to the minus 3. Now, who has problem converting this into decimal on their calculator? Does everyone know how to get this back into decimal on your calculator? Does anyone have any problem reading this on their calculator? Your calculator will read 5 times 10 to the minus 3. Does anyone have any problem reading this on the calculator? I guess not then, okay? Now, do you know how to key this into your calculator? 5 times 10 to the minus 3. I don't mean click answer. I mean, do you know how to press this into your calculator? Because this thing can come out in maths and physics as well. Do you know how to key this 10 times 10 to the minus 3 into your calculator or not?
Yes.
Yes.
Okay. Does anyone not know? You gotta admit to me, okay? Because I'm gonna show you if you don't know. Okay. Does anyone not know how to key this into your calculator? Okay. I assume everyone knows that. So you press the number, and then there is that EXP button. When you press EXP, it means times 10 to the, and then you press minus 3. So you press that, you press that, you press that. That means 5 times 10 to the minus 3. Make sure you understand what it means, okay? To convert this number to decimal, I think there is a button called ENG or something like that. You should know how to convert this back to decimal, okay? People have made a lot of mistakes on this in the past, yeah? So make sure you don't get confused. The next thing is you want the simplest ratio of the atoms. So find the lowest number. This is 5, but this is 5 times 10 to the minus 3. Actually, this is the smallest out of all of these because you know about mathematics, 1, 2, and 3. So this is 0, 0, 5 like that. I'm not going to do that manually. I just do that on my calculator. 0.015 divided by 5 times 10 to the minus 3. 0.03 divided by 5 times 10 to the minus 3. So the people who will make mistake in this question are the people who cannot read the number, and you will already have messed up from the very beginning. So this one gave me 6, and this one gave me what does this one give me? Hang on. Does anyone have any problem keying this under the calculator? I assume no problem then. Okay. So your empirical formula, make sure you label. This is only the first part of the question. Yeah. The empirical formula is C3H6O. Am I correct? Yep. Okay. This is of the ester. Now this is empirical formula. Now they want the molecular formula. Is there a previous part of this question? Now there is no way I can get the molecular formula. Oh yeah, there is a way because they give me the molecular mass. What am I talking about? So molecular formula is the actual number of atoms in one single molecule. So what is the MR of the empirical formula? So the MR of the empirical formula, you can multiply it by a factor, by a scaling factor, will give you the MR of the molecular formula. Because how many atoms are there actually? Well, 116. How many atoms are there in the empirical formula? So 12 times 3 for the carbon, and then 6 times 1 for the hydrogen, and then you have 16 times 1 for the oxygen. So you get 58. So 58 times the factor. So your job is to find out what factor is it. Your factor is going to be 116 over 58, which is 2. So, oops, sorry. So I'm running out of space here. Your factor is 2, but they want empirical and molecular formula. Your factor is 2 does not mean that your molecular formula is 2. It means that your molecular formula is going to be 2 times the whole thing for empirical formula. So the factor, put the whole empirical formula in a bracket and then multiply the whole thing by 2 3 times 2 is 6. 6 times 2 is 12. Oxygen times 2, 1 times 2 is 2. Okay, hopefully that makes sense there. I forgot who asked the question just now. All right, so that's how you get the 3 marks. You probably get 2 marks already when you can get the empirical formula. Doing this last step to get the molecular formula, multiplying this correctly, the whole thing, not just the first one, the whole thing, because when you simplify this, divided by 2, you get 3, divided by 2, you get 6, divided by 2, you get 1, simplest ratio of the atoms. That is empirical formula. Actual number of atoms in one single molecule, that is molecular formula definition. All are part of year 9 definitions there. Okay, any other questions people want to ask? Oh, don't be shy. You have me for like the whole another 25 minutes. Any other questions you want to ask?
Paper 1.
Question?
Number 30.
Sorry, I'm going to scroll down. Yeah. I give you a headache. Number 30. Yeah. All right. This one was not typed properly, but it should be HCO2H. And this thing is wrong, I can tell you, because what in the world is wrong with this? I'm pretty sure this is wrong because that is number 2, that's number 3. So this is just the wrong numbering. It should be that. Okay, so make sure everyone, you take note of it. Yeah. If you have done organic chemistry, you will know that this is how it looks like. Hydrogen forms single covalent bond, carbon form 1, 2, 3, and 4 covalent bond, oxygen form 2 covalent bond, hydrogen form 1 covalent bond. When you have CH3OH, carbon there form 4 bonds. So the same deal, the oxygen form 2 covalent bond, the hydrogen each form single covalent bond there. This one is fine, this one is fine. It's just that these formula are wrong. Now, for which molecules are the empirical and the molecular formula the same? If I were you, I would jot down on the side there, what is the molecular formula first? Because it's easy to count the actual number of atoms in one single molecule. I don't need to draw this out. This is multiple choice. I have 1 minute. This is what is going in my mind. I have 1 minute. I must be able to do this in 1 minute. Okay, don't waste your time. Count 1 carbon, so C1. This is molecular formula. I know they ask empirical first, but do the molecular first. Then you can simplify later on. Then there are 2 hydrogen, so C1, H2, O2, which means it's already 1 carbon. You cannot simplify to the lowest, simplest whole number ratio anymore. 1 is the lowest. So, you know, it has got to be C1, H2, O2 also, because you cannot simplify 1 to the other whole number again. So this one, they're asking for the same. So this is the same. All right, so 1 is definitely true. So you have 1, 1. This one doesn't have 1. This one is wrong. This one doesn't have 1. C and D are wrong. Okay, so far, whoever asked this question, this is about eliminating possibilities. So you don't need to check for everything, because now I know number 1 is correct. So C and D must be wrong. If C and D are wrong, I'm left between A and B. Look at A and B. 1 and 1, okay. 2 and 3 and 3. So what is my job here? If I check number 3, I'm wasting my time because, you know, 3 is in both the answer. So what is the point of checking number 3? So I should check number 2. If number 2 is correct, then A must be the answer. If number 2 is wrong, I don't need to check anymore. B must be the answer. Do you get the logic? Yeah. Okay. So this is all about logic. All right. Now I'm going to show you for number 2 then. Number 2 is ethanoic acid. There are 2 carbon, C2, H, and then 3 plus 1 is 4 hydrogens, and then O2. That is molecular formula. I can simplify by dividing by 2. 2 divided by 1, 2 divided by 2, I get 1, sorry. 4 divided by 2, I get 2. And then 2 oxygen divided by 2, I get 1 oxygen. You might not see it like that, but imagine 2 is to 4 is to 2. Divide by 2, the whole thing, you get 1 is to 2 is to 1. 1 carbon, 2 hydrogen, 1 oxygen. They are not the same. They are not the same. They are not the same. Therefore, number 2 is wrong. Therefore, B must be the answer. Okay? Well, obviously, you'll be able to do it faster in 1 minute if you don't have to explain to someone else. You're just explaining to yourself in your head. Okay? Next question. Any other questions?
Paper 2.
Hang on, paper 2. Yep. Do you know what year?
No,
Or
November 2007.
6. A6, November 2007, A6. Okay. Now this is about the thing in the syllabus where it says, I give you information, you write me the equation. Whatever equation you write, they don't say balance, right? But whatever you write must be balanced. If you try to write an equation which is not balanced for Cambridge exam, you are dead. Okay, you lost the marks right away. Now this is potassium nitrate. They don't give you the formula of the potassium nitrate, but they give you the potassium nitrite. This is the one with the ITE. So that thing is K plus NO2 minus. We know the nitrate comes from nitric acid. Nitric acid is HNO3, so nitrate is NO3 minus. And we're combining with a group 1 metal, so it's a K plus NO3 minus. When you do the crisscross of the 1 and 1, plus 1 cancel minus 1, so potassium nitrate is KNO3, and that will decompose. So they don't do anything, they just decompose to give you KNO2 plus oxygen. Now, this is oxygen, not as an empirical formula, but oxygen as a species. And we know oxygen as a species is this diatomic molecule. Oxygen that we are breathing in is not oxygen atom, it's actually oxygen molecule. So they form a double covalent bond. Because oxygen in group 6, they want to complete the outer shell. So they share 2 out of the 6 valence electron. And of course, you're expected to be able to draw the full outer shell of an oxygen molecule like that. So I get O2. If you write this answer, you get 0 straight away. Because potassium is balanced, 1K and 1K, 1 nitrogen and 1 nitrogen, 3 oxygen total on the left, 2 oxygen here, plus 2 oxygen is 4 oxygens. Anything which is not balanced, you get kicked out immediately. Okay, so I just need 1 oxygen atom, but I have oxygen molecule. So what some people try to do is, some students try to be clever, they just like, oh, I write like this. Nope, that is wrong because oxygen exists as a diatomic molecule. What can I do? Well, you can go difficult way, or you can do the easier way. I cannot change this identity, but I can put a half in front. This is probably the first time you've seen half in your entire life, okay? Half times 2 give you 1. There are 2 oxygen atoms in 1 molecule. You can put a half in front because half oxygen molecule means half times 2, I get 1 oxygen atom, which is what I need. Now, some teachers and some students, they really don't like fraction, okay? I like to work with fraction because it gives you the smallest number possible. You can times 2 both sides, then you get 2KNO3, then you get 2KNO2, then you get O2. Half times 2 is 1. So now I have 4 oxygen, 2 times 2 is 4, 2 times 1 is 2, 4 plus 2 is 6 oxygen, 2 times 3 is 6 oxygen, 2 potassium, 2 potassium, 2 nitrogen, 2 nitrogen. The top one I've written is correct. Cambridge will definitely give you the marks. Here is also correct. You will definitely get the mark. This is correct because equation is a symbolic representation. If your equation is balanced, even with a half, your mole ratio will work. Your mole ratio, your mole calculation will still be correct. Why? Because this times 2 give you that. This divided by 2 give you that. These are just symbolic. Okay? So, it's just up to you which one you want to use. I personally prefer this one, but, some students prefer this one. So it doesn't matter. Both are correct. Any other questions? The more questions you ask, the more worth it is your time, because otherwise you're just being here for 1 hour, not learning anything. Any other question you want to ask? Chemical formula and equations. Sorry, you're breaking up, dear.
For 2. June 2007 AH.
June 2007. So that is going further down. June 2007, June 2007. Hang on, I can't find June 2007 somehow. Is that all the way down? Seems like these are all November. November. June 2007, yeah? June 2007. A8. Okay. Oh, this is scary looking questions. All right, now, what do we have here? This thing is all about what do you understand by relative formula mass? Relative formula mass is also MR, but it's MR for ionic compound. It's just that ionic compound, we don't call them molecule. That's why they call it relative formula mass instead of relative molecular mass. But the way you calculate it is still the exact same thing. So add up, total up, sum up the individual atom. If I were you, read the formula, okay? So here I have X number of H2O molecule. In one H2O, I have 2 hydrogen. So 2 times 1 plus 1 oxygen. So I get 18. So altogether there, I have 18X. The dot there means you add it together. It's not mathematics, it's just that they have different compounds combined together. These are mixed salt, and this is a hydrated salt. Hydrated means it has got water of crystallization as it is stated in your syllabus. Now the copper 2 hydroxide, if you look from your periodic table, let me just open up periodic table, yeah. So copper is in the transition metal series, so it's 64. So I've got 64 plus 2 times 17. Where do I get the 17? 16 plus 1 because 1 oxygen and 1 hydrogen. 17 times 2 because I've got 2 of that hydroxide. So 64 plus 17 times 2, I get 98. Okay, do things step by step. Now this thing inside the big bracket, that's the trickiest one of all. But then think about it and you can make your life easier. Sum up everything, sum up the carbon inside the bracket first. So there is 1 carbon and 2 carbons, so C2. There is 3 hydrogens, so C2H3 O2, and then the whole thing is multiplied by 2 like that. So what I do is I can sum up again. 2 times 2 is 4, so C4, and then 3 times 2 is 6, so it's H6. 2 times 2 is 4, okay? And then outside the bracket, there is another 2. There is another 2. So what do I need to do? I can sum up again. I can just total up again. So that means I have 2 copper, and then 4 times 2 is 8. 6 times 2 is 12. 4 times 2 is 8. Now, what I can do is 2 of the copper, 2 times 64, 8 times 12, 1 times 12, 16 times 8. How do you work out MR? You sum up the individual relative atomic masses. So what I do is I just press my calculator. If you are the type of student who would just jump straight for the calculator and just press it straight away, you have made a terrible mistake. You might make a mistake along the way. So for this first block, for this big block here, I get 364. For this second block, I get 98. For this third block here, I get 18X. I don't know how many water molecules I have, but I have X number of water molecule. Sum up the mass, that gives me the MR of 552. Well, now you have your usual mathematics. So 364 plus 98, that gives me 462. When I move to the other side, it becomes minus 462. So you're just doing mathematics now instead of chemistry. The only chemistry is what does MR mean? So there's 90, and you have 18 times X. So move the 18 to the other side. That becomes divide. 90 divided by 18, you get 5 there. As you know, water crystallization, whole number there. Sounds good. Okay. Still tricky or not very tricky at all? I don't know. Okay, so only for 2 marks. That means technically you only have 2 minutes. If you make a mistake by pressing a calculator, tekan, from the very beginning, if you make a mistake, then you are gone. It's better identify, total up the number of carbons, hydrogen and oxygen, the copper for 1 bit, sum them up from your periodic table, press your calculator and get the mass, and then get this one in terms of X, and then you should be able to sum them up to get 552. Any other questions? Still have around 12 minutes. Come on, I'll try and do more questions with you. Anything else on empirical, molecular, writing equations, balancing equations, something difficult for you? I hope people are still there because, we don't turn on our camera, but, I'll be here for the next 12 minutes. Any other questions you want to ask? Multiple choice, structured questions. Nothing at all. This topic is super easy. Well, next week one is on more concept, and I hope you'll have a lot of questions on more concept for me because there's a lot of questions on more calculations. Do you want me to go through some of the more calculations questions instead?
Yeah, sure.
Okay, all right. I'll show you what are my usual strategy, yeah, and hopefully it will help you somewhere along the way. Okay. Now, okay, this is the first question. Okay. So I'll show you what I normally do. You can hopefully apply the same concept when you approach some of the problems. Now, this is a balanced chemical equation. So this is N2H4 plus O2, giving N2H2O. The first thing you must have is balance equation. The first thing you must have is a balance equation. They want the volume of oxygen. So they want this volume of oxygen. This volume of oxygen is a gas. So there are three different things you can have. The solid, which has to do with reacting masses. Actually, it's not just solid. The first concept is reacting masses, because even solid, liquid, or gas will have masses. If you have reacting masses, we know mole is equal to mass over mR. We have the next one, which is solution chemistry. Solution means dissolve in water. So it's not a gas. Do not get confused. It's not a gas. So this thing, N equal to CV, and this is the one which always come out in titration. This is concentration in mole per dm cube, which means your volume there must be in dm cube. And this is the one where people always forget. This is in dm cube there. 1 dm cube is 1000 cm cube. So if you divide both sides by 1 cm cube, divide by 1000, 1 cm cube is going to be 1 over 1000 dm cube. So convert cm cube to dm cube by dividing by 1000 or multiply by 10 to the minus 3. The very last one is to do with gases. If you're dealing with gases, the mole of a gas is the volume of the gas divided by the molar volume of the gas. This is stated in your periodic table at the bottom. The molar volume of gas is stated as 24 dm cube for 1 mole of any gas. And this is at room temperature and pressure, as stated in the periodic table. It says 1 mole of any gas, 1 mole of any gas occupy this much volume at room temperature and pressure, which is 24 dm cube per mole. Now this thing here, this is the volume of gas. If this is dm cube per mole, that volume of gas must be in dm cube. That one must be in dm cube. How about if your volume is in cm cube, where you can convert it to dm cube by dividing by 1000? Or you can have the volume in cm cube but divide by 24,000 because you convert this to cm cube per mole. So just 3 formulas you must be able to identify. Are you having reacting masses? Are you having solution chemistry? Are you having gaseous kind of chemistry? Here we have volume of oxygen. This is a gas. So that means for this one, we need this equation. The next one is 1 ton of hydrazine. 1 ton. 1 ton is 10 to the 6th gram. So this is to do with reacting mass. So we have 2 different concepts here. We have 2 different formulas. One is to do with reacting mass. One is to do with the gaseous chemistry. How in the world do I set up my equations? Okay, how in the world? Well, I want to find oxygen. So this is what I normally do, okay? I know your teacher would have probably asked you to do it step by step. I'll just show you what I normally do. I'm not asking you to, definitely follow my method. As long as you can get the correct answer, no one can fault you, right? As long as you can get the correct answer, okay? I label. The N there stands for mole. Mole of O2 divided by mole of hydrazine. Why do I do that? Because I want to find oxygen. So I put the oxygen on top. I don't put the volume of oxygen. I put the mole. Mole ratio. From the balance equation, 1 mole of O2 reacts with 1 mole of N2H4. 1 mole is to 1 mole. The first thing you do is read the balance equation. 1 mole of O2 reacts with 1 mole of N2H4. Follow. Whatever on top belongs to whatever on top. Whatever at bottom belongs to whatever at the bottom. Can you have it the other way around? Of course. You just need to follow your math. You just need to follow your own label. On the right-hand side, this is the actual happening. This is from balance equation. This label is just for me to understand. Make sure I don't make any mistake. This is a gas. I want the volume of oxygen gas. So I need to use this formula. And this thing on top is for oxygen. So I use this formula for oxygen because this is the information I want for the oxygen. This is the volume of oxygen. They don't tell me in dm³ or whatnot. So I just use it in dm³. If I have it in dm³, this will be divided by 24. The volume of gas in dm³ divided by 24 dm³ per mole, that is the actual mole of oxygen there. Now at the bottom, I have the mass. So mR of hydrazine. Why do I need the mR of hydrazine and not O2? Because the O2 is not reacting mass they want. But we are given the reacting masses of hydrazine. So I need to use mass over mR. So I need the mR of N2H4. 14 times 2 plus 4 times 1 is 32. So at the bottom there is your mass over mR. I must convert the tons into gram because in mass over mR, the mass is in gram, the mR is in gram per mole. So 10 to the 6th gram divided by 32. Now, this is your mathematics. Make this the subject. This is the beauty of this method, which I have been using my entire life. So that is 1/1, doesn't change on that side. 10 to the 6 divided by 32 equal to the volume of O2. This is in dm cubed divided by 24. Move up the 24 to the other side. So, you just rearrange your equation first instead of pressing your calculator and wasting time. Guess what? This is a one step, and I get the whole thing by solving the mathematical equation. So 1 times 10 to the 6 divided by 32 times 24, I get 750,000. And this one will be in dm cubed because I have said that this is in dm cubed. That's why I did division by 24. I get this answer, must have the correct unit there. Okay, let me try and show you another way that I can, manipulate this when the ratio is not as good as that. When it's 1/1, it's easy, right? Your problem is probably when it's not 1/1. Let me try and show you something else. This is hydrogen iodide. Now, hydrogen iodide, they want the mass here, but we're also given the mass of hydrogen. So here is to do with reacting mass. So I have to do mass over mR. The hydrogen is also reacting mass, so I have to do mass over mR. So identify which of the three things. Do you have reacting mass? Do you have solution? Or do you have gases? The hydrogen iodide is 2 mole of Hi that comes from 1 mole of H2. 2 mole of Hi, 1 mole of H2. I want the hydrogen iodide. So the mole of hydrogen iodide over the mole of H2 from my equation, I label from my equation, this is mole and mole. From my equation, 2 mole of Hi reacts to 1 mole of H2. Trust me, if you do this method, if you set it up with your exercise questions or test questions that you got incorrectly previously, you should be able to get the correct answer. On the top here, I want the mass of the Hi. So this is reacting mass, as I said, mass over mR. So work out your mR of Hi. So go to your periodic table, and your iodine is 127. Your iodine is 127 plus 1, so that is 128. Your mR of hydrogen is H2, so 2 times 1 is 2. So mass over mR, this is the actual reacting mass, give you the reacting mole, mass over mR. Okay, now at the bottom, I have H2, so that one is 45.3 gram of H2 divided by 2. And now I already have the mole ratio from the balance equation. That is what you do when you, half or multiply by 2 or whatever, when you do multi-step kind of calculation. When I move this number at the bottom to the top, do not change this because this remains on the left. So keep it on the left. You just multiply by the denominator. All you're doing is you're doing careful mathematics as well as careful physics, and you should be able to get the calculation correctly. Look at the 2/1, doesn't change. Look at the 45.3.2 over 2, doesn't change because I'm just moving the thing at the bottom there. So in the end, you just need to press your calculator. As you know, the mass over mR there, the mass must be in gram. This mass is in gram, so this mass is in gram. Get your answer, it will be in gram and it will be correct there. If you don't believe me, you can try this method where you label the mole of something that you want, the mole of something you have, get the correct balance ratio from the question, and then think, do you have mass over mR, your first case study, or are you given solution, meaning titration? Is it concentration times volume of the solution? Of course, with the correct units. Or are you talking about gases where you need to use this? Mole versus mole, mole versus mole, mole versus mole. All we are doing is we are just thinking about, do we have reacting masses, reacting volumes of gases, or do we have solution chemistry? Okay, so we have around 2 minutes. I'll probably just use this time to quickly go through this next question. We have some hydrochloric acid, so 2 mole of HCl, and this is this thing here. We have, this is HCl, this is HCl, and this is the calcium hydroxide. So CaOH twice, I need the concentration. So I want to find calcium hydroxide. I label calcium hydroxide on top. I put HCl at the bottom. This is very clearly solution chemistry. Solution chemistry, very, very clearly. From that thing here, you have 1 mole. You have 1 mole of calcium hydroxide. You have 2 mole of HCl. Label. Okay, 1 mole of calcium hydroxide, 2 mole of HCl. Now on the right hand side, because I know mathematically equal means equal, so the top bit is for the calcium hydroxide. Solution chemistry, N equal to CV. This is volume in cm cubed, so I need to convert this to dm cubed. This is volume in cm cube. I need to convert this to dm cube, both by dividing by 1,000. The thing on top is for the calcium hydroxide. So what do I need? I have the concentrations of the calcium hydroxide. This is what I want to find in mole per dm cube. So this is multiplied by 20.0 over 1,000. At the bottom, I have 0.0153 multiplied by 6.00 over 1,000. Move this whole thing to the top. Do not change the half because you know mathematics, you are not doing anything to the half. So you don't change anything to that half, which is already present there. I guess a lot of people are scared about the mathematics. Now this is time 20.0 over 1,000. I can move this to the other side by dividing. Divide the whole thing by 20.0 over 1,000. Press your calculator correctly. Use bracket. Do the first thing first on top and then do the bottom. And in that just few steps, you can get the concentration of the hydroxide, and that will be in mole per dm cube. You can try with any previous examples you have been given, set out the mole ratio, identify which of the 3 formulas for the mole that you need to use, and you will be going home nice and happy. Try the rest of the question, well, as many as you can, and then next week you can ask me any questions that you couldn't get. Okay, good. We'll probably just stop it there. It's 11:01. I don't want to be scolded by your next teacher, so I'll just stop it here, and feel free to just leave because I will continue the next session with assembly. Okay, thank you everyone. Have a good day.
Thank you, sir. Have a great day.
Okay, bye-bye.
Yes, sir.